Hello, I'm Angelo Pietroforte, Power Products Field Application Engineer for RFMW. I am here to demonstrate the ACT41000 plus ACT43750 REV01 reference design from RFMW, which provides proper power management while optimizing performance for gallium nitride or gallium arsenide RF power amplifiers. The design features two Qorvo devices. The first is the ACT41000 RF point-of-load regulator with programmable output, and the second is the ACT43750 RF point-of-load drain switch controller with gate bias regulator. The ACT41000 provides clean regulated power of 24 volts DC at 4 amps or less to the drain of the gallium nitride power amplifier from an external source. And here it is on the EVK in its QFN package. The test setup includes the following: a 40 volt max input power supply, a function generator for drain pulse applications, oscope for showing the drain voltage, gate voltage, and IDQ of the power amplifier, computer with GUIs, one for the ACT43750 and one for the ACT41000, a USB to I2C dongle interface, and then a Qorvo QPA 2612 GaN power amplifier. Next, I will demonstrate the autocal feature. First thing I do is I bring up the ACT41000. And what I want to do here is I want to show you the ease at which using I2C to change output voltages. So I pick 12.2, I do a write, and you'll notice the oscilloscope dropped to 12 volts. Now to bring it back to 24 volts, I just do another write, and you'll see the yellow line bumped up to 24 volts. Now, to show you the gate bias feature, I go to the ACT43750 GUI, and I do a read to make sure it's communicating through the dongle, and I do an enable gate, and we'll see the gate is at 0 volts right now, but it's going to go down to minus 4.5, and it does. The next thing we want to do is we want to do the autocalibration feature, which is this part of the GUI. And we do that by setting a trigger on the oscilloscope, and we click auto calibration, and you notice a lot of things have taken place instantaneously. The gate drive level, which is this orange trace, gets locked in when the optimum quiescent current is reached for the given power amplifier. For the QPA 2612, that's 250 milliamps. So our current probe is monitoring that, and as soon as the transistor gets pinched, you can see the voltage drops, and that's the optimum. The drain voltage drops to 0, and that's the optimum position for the gate, and that's at minus 2.6 volts. Autocal can be done at any time to compensate for drift that occurs over time or over temperature. So it's a really powerful feature available in the ACT43750. As an added feature, we previously mentioned the ACT43750 provides pulsing to the amplifier for radar applications. I will now demonstrate that. So here in the GUI, what we do is, previously we pushed the auto calibration. We could see we have 2.5 volts on the gate. That's the optimum gate voltage for this power amplifier. So now we're going to enable the gate, and you're going to see this gate voltage go up again. And it does. And now we're going to enable the function generator that switches the drain continuously. And we have it set for 5 pulses of 1 millisecond each over a period of 10 milliseconds. So now I'm going to turn it on. You're going to see some square waves on the oscilloscope. And here we have the drain voltage and the 5 pulses I had mentioned over here on the signal generator. And here is the drain current going up to 250 milliamps. And then when the function generator shuts it off, it drops back down to 0 and then back up to 250 milliamps. Again, continuously. And that concludes the radar application of the ACT43750. Thank you. And if you need more information, we have eval boards available. Ask your local field application engineer. Thank you for your time.